Okay, let's unpack this. Think about how fundamental messaging is, right, to our daily lives. We send texts constantly, assuming they just, well, work.
Yeah.
But what if I told you that the current system, the SMS technology we all rely on, is actually wrestling with some serious limitations, things you might not even realize are impacting you?
It's really true. We've gone through a stack of sources today, and yeah, they confirm SMS is useful day to day, but they also really lay bare its significant pain points.
Yeah.
But here's where it gets really interesting. These same sources propose a potential solution, and it sounds like something out of a, well, near future sci-fi novel.
Right.
It blends what they're calling quantum technology with something called Pocket Boss AI integration.
Exactly. So our mission for this deep dive is basically to get to the bottom of these sources. We need to fully grasp the challenges with today's messaging.
Okay.
Understand how this proposed solution aims to fix them, looking at both the quantum core and its AI brain. Explore where it could actually be used, in the real world today. And finally, take a peek at the truly ambitious future they seem to envision.
Let's jump in then. The sources are pretty blunt about the shortcomings of SMS as it is now.
Yeah, they start with something we've probably all experienced, delivery delays. You hit send, and sometimes that message just, well, it doesn't arrive instantly.
No.
It could be minutes, sometimes longer.
And that lag, as these documents point out, can be more than just annoying. I mean, it can be critical if you're waiting on something time sensitive.
Definitely.
And hand in hand with that is a major red flag the sources raise: security issues. Standard SMS, well, it often lacks end-to-end encryption.
Right.
Your conversation might travel across networks in a way that leaves it vulnerable, not truly private between you and the person you're actually talking to.
Which, in today's world, with privacy being such a huge concern, that's kind of a non-starter for many things, isn't it? And beyond simple text, what about functionality? The sources point out the limited functionality. It's basic text, maybe a low-res image or video if you're lucky, but nowhere near the kind of rich media we're used to in modern apps.
Right. It's like comparing a digital postcard to, I don't know, a full interactive website. It's just not the same league.
Good analogy.
And that limitation then spills into integration problems, trying to connect standard SMS capabilities into other digital workflows, like integrating with a business system or using it seamlessly with other apps. It's often difficult, maybe even impossible, because it just wasn't built with that in mind originally.
And for anyone trying to get any kind of performance insight, maybe a business setting alerts or even just, wanting to know if a message was delivered in red, the lack of analytics is a major blind spot. You're basically sending messages into a black box.
Totally. So you see, these aren't just minor inconveniences. They're described as systemic issues. Unreliable delivery, fundamental privacy gaps, really bare bones capabilities, poor connectivity, and no real data on performance. The sources argue that these collectively are the pain points, and they demand a fundamentally new approach.
And that new approach, according to this material we've looked at, starts with the quantum layer. It seems designed to completely overhaul the underlying messaging infrastructure, starting right with that security problem.
Yes, the foundation is what they term quantum encryption technology. The idea, as it's described, is to use principles from quantum mechanics to create inherently secure messages.
Okay.
How? Well, each message gets a unique quantum signature. And what's particularly fascinating, and this is a core tenet of quantum physics, is that if someone attempts to intercept or even just observe a quantum message, its state changes. And that immediately alerts both sender and recipient that privacy has been breached. That's the built-in eavesdropping detection they talk about.
Wow. Okay, so unbreakable security. And, if someone even tries to look, that's a significant step up from standard encryption, if it works as described.
Huge step.
But what about those annoying delays? Does it fix that?
This is where they introduce the lightning-fast delivery system. The sources make a pretty bold claim here, suggesting instant messaging.
Instant.
Reportedly following quantum entanglement principles. Now, entanglement is that strange quantum phenomenon where two particles become linked, instantly influencing each other no matter the distance.
Right, the spooky action at a distance.
Exactly. Now, the sources don't detail the exact mechanism of how this applies to message delivery.
Okay.
But the concept they put forward is near simultaneous transmission. It supposedly uses both quantum networks, where available, and traditional cellular networks to ensure connectivity. And they promise a 99.9% delivery guarantee with real-time confirmation.
Quantum entanglement for message delivery. Okay, that truly steps into the futuristic zone.
Yeah.
If they can pull off near instant transmission with that kind of guarantee, that would definitely address the delivery delay issue head on
Big time.
and the limited functionality problem.
They move well beyond basic text with multimodal communication. This system is apparently built to support text, voice, image, and video content right from the get-go.
So all the formats.
Yeah, and they also emphasize rich media capabilities you'd expect in modern apps, like polls, interactive buttons, quick replies, that sort of thing.
Okay.
The sources mention compressing all this diverse content using quantum data techniques, though again, the specifics of what quantum data actually is aren't fully detailed, beyond saying it's reportedly very efficient.
Right. So moving from simple text to interactive content, all within this presumably secure and fast pipeline, how does it decide the best way to actually, send the message?
That's handled by what they call a smart routing algorithm, and this is where AI comes into play even at the infrastructure level. The algorithm uses AI to prioritize messages, maybe routing critical alerts faster, for instance. It automatically selects the optimal network route based on real-time conditions like congestion. And according to the sources, it even factors in cost optimization through intelligent carrier selection. It's not just about sending the message, but sending it via the best possible path at that moment.
Okay, so that's the core quantum infrastructure: secure, fast, multimodal, and intelligently routed. Seems pretty comprehensive. But then the sources introduced the second major layer, this Pocket Boss AI integration. This sounds like adding an intelligent assistant right on top of the messaging system itself.
That's exactly the idea. This AI layer is positioned as transforming the messaging experience and adding significant functional capabilities beyond just sending and receiving.
How so?
Well, the sources detail intelligent message management. This involves using natural language processing, that's AI understanding human language,
Right, NLP.
to categorize incoming messages, automatically detect and filter spam, which would be nice.
Oh, definitely.
Organize your inbox based on priority, and even suggest context-based smart replies.
So the AI isn't just sending messages, it's actively helping you manage the inflow and even compose responses. That could be incredibly helpful for dealing with information overload.
You'd think so.
What about more active assistance features?
They list several personal AI assistant features. A key one is voice-to-text transcription, and they claim a high accuracy rate, like 98%.
Wow.
It apparently offers multi-language translation support for over 50 languages directly within your conversations.
In real time.
The implication is seamless translation, yeah? And the sources describe the ability to handle tasks like meeting scheduling through a conversational interface. Meaning you could potentially type something like, schedule a meeting with Sarah next Tuesday afternoon, and the AI would handle the back and forth coordination.
Seriously, that would be amazing.
It also assists with setting reminders and automating follow-ups based on your messages.
In AI, they can understand meeting requests via text and potentially handle the scheduling. That's powerful. The sources also seem to heavily emphasize business integration capabilities for this AI layer.
Yes, this appears to be a major focus, a key use case. The AI is designed to integrate seamlessly with CRM systems, customer relationship management systems,
Okay.
allowing for real-time customer data synchronization. So businesses could potentially manage sales pipelines directly through SMS conversations, automate marketing campaign execution, and get a real-time analytics dashboard powered by the AI, providing insights into message performance that, as we said, are completely lacking in current SMS.
This really moves messaging far beyond just peer-to-peer chat. It turns it into a genuine, intelligent tool for businesses to interact with customers. Are there any other sort of advanced AI features the sources mentioned?
They do list several advanced functions. Sentiment analysis, which means the AI can detect the emotional tone of messages.
Okay, useful.
Predictive text that's context aware, so potentially suggesting not just the next word, but maybe the next phrase based on the conversation flow.
More than standard autocomplete.
Exactly. Behavior learning to recognize your habits and preferences for automation. Smart automation for setting up rule-based message handling, like automatically forwarding messages from specific contacts or about certain topics. And perhaps the most surprising one mentioned is voice cloning.
Voice cloning. What for?
For potentially generating personalized voice messages in your own voice.
Okay, whoa. Voice cloning for personalized messages.
Voice cloning for personalized voice messages in your own voice.
Okay, whoa. Voice cloning for personalized messages. Okay, whoa. Voice cloning for personalized messages. That definitely pushes the boundary of what we think of as messaging.
It does raise some interesting questions, doesn't it?
For sure. So, okay, we've got this potentially revolutionary quantum base combined with a highly intelligent AI layer. The sources must make a case for why this whole package really stands out. What makes it different from other messaging solutions, according to these documents?
They highlight several points regarding its competitive advantage. First off, technical superiority. They claim it includes the first-to-market quantum SMS encryption.
Which is a big claim.
A very big claim. They also mention patent-pending AI integration technology and proprietary compression algorithms. These are presented as unique technical foundations that presumably competitors lack.
Being first with quantum encryption, if that's verifiable, would certainly be a massive differentiator. What about the user experience? What's the claim there? Is it easy to use?
User experience is definitely emphasized. The sources describe an intuitive interface design with a claimed, maybe optimistic, zero learning curve.
Zero, okay.
They also highlight practical benefits like cross-platform compatibility, working on different devices, different operating systems, and importantly, offline functionality with sync capability.
Offline functionality. That's actually huge. Being able to compose messages even without a signal and they just send when you're back online.
Yeah, that's a definite practical gain over many current systems.
And for potential large-scale adoption, maybe by businesses or governments, is scalability addressed? Can it handle volume?
According to the sources, yes. They position the system as using enterprise-grade infrastructure. It has an API-first architecture, which means it should be easy for developers and businesses to integrate with.
Okay.
They also mention offering white label solutions for customization and leveraging global carrier partnerships. All of this, they say, is designed to ensure it can handle large volumes of traffic and integrate into existing systems.
Okay, so it sounds like it's built to be robust and adaptable for big users and potentially global reach. Let's try and ground this a bit more. The sources provide specific real-world applications across different sectors. Where could you actually see this quantum AI messaging system being used?
Right, the practical side. They list examples in healthcare first. Imagine secure patient appointment reminders with that AI scheduling capability we talked about. Confidential medical report sharing using the quantum encryption, rapid emergency alert systems, or even streamlined telemedicine consultation booking via a chat interface.
Healthcare absolutely needs that level of security and reliability. That makes sense. What about e-commerce?
In the e-commerce industry, potential uses include, well, instant order confirmation and tracking updates, obviously, but also personalized product recommendations sent directly via message based on AI analysis of your buying habits. Automated customer support chatbots handling inquiries through messaging, and even payment gateway integration via SMS, essentially turning a message thread into a secure transaction channel.
Using messaging for purchases and support, that really changes the customer interaction model, doesn't it?
Completely.
Financial services, always a big one for security.
Absolutely. For financial services, applications include real-time transaction alerts, potentially integrated with AI-powered fraud detection, secure account balance inquiries through a chat interface, automated loan application status updates, and even simplified interactions for investment portfolio management via messaging. Again, security and speed are absolutely critical there.
Handling sensitive financial info definitely requires robust security. Makes sense. And they mentioned the education sector too.
Yeah, in the education sector, examples given are things like efficient exam schedule notifications, maybe online class coordination and communication, uses that leverage the speed and the potential for rich media alerts, maybe interactive elements.
So these examples really show how that combination of speed, security, and AI intelligence could fundamentally upgrade communication workflows in some really crucial industries.
Exactly.
Finally, the sources peer into the future a bit. What's on the roadmap for this technology? The looking ahead section sounds pretty ambitious.
It really, really does.
Yeah.
The future plans mentioned include potential for quantum internet integration, suggesting connectivity across future quantum networks whenever those become widespread.
Okay.
They talk about AR/VR messaging for truly immersive communication experiences.
Messaging inside augmented or virtual reality. That is definitely pushing boundaries.
Yeah.
What else?
Blockchain verification is mentioned. For message authenticity certification, maybe creating an immutable record to ensure messages haven't been tampered with. Useful for legal or financial contexts, perhaps.
Interesting.
They also envision IoT device integration, Internet of Things, allowing you to potentially control smart home or industrial automation devices via secure, intelligent messages.
Controlling your smart devices with a quantum secured message, potentially prioritized by AI.
Yeah.
Fascinating possibilities there. And the final one listed is perhaps the most speculative of all.
Yes, the potential for neural interface capability,
Right.
suggesting down the line integration with brain-computer interfaces for communication that bypasses traditional input methods like typing or speaking.
Communicating directly from your thoughts via a messaging system. Wow. That is squarely in the realm of science fiction right now, but the sources actually put it on the roadmap.
They do. It's out there.
So we've taken quite a journey through these sources today. We started with the very real, often frustrating pain points of current SMS technology. The delays, the security gaps, the basic features, the lack of integration and analytics.
And then we explored this proposed solution, detailed quite extensively in the material, which aims to address these problems head-on. It combines the potentially game-changing capabilities of quantum technology for that unbreakable security and lightning-fast delivery with a powerful, intelligent pocket boss AI layer.
Right, for managing, automating, and adding all that rich functionality to your messages.
Yeah.
We've looked at the claims for why this system supposedly stands apart, its technical foundation, the focus on user experience, and that built-in scalability.
We covered its potential applications across healthcare, e-commerce, finance, education.
And we've glimpsed a truly ambitious future roadmap that stretches from things like quantum internet and AR/VR messaging all the way to neural interfaces.
It paints a picture of communication that's very, very different from what we know today.
Which leaves us with a final thought for you, the listener, to consider, drawn directly from these sources. Given the possibility of technologies like quantum entanglement being leveraged for message delivery, promising instant, truly private communication, and the potential future integration of technologies as profound as neural interfaces, how might our fundamental understanding and even our experience of communication itself be irrevocably changed?
It really forces you to think beyond just sending a text message on a screen, doesn't it? You have to consider a world where messaging could be instantaneous, completely secure, deeply intelligent, and integrated with our digital and even physical environments in ways we're only just beginning to imagine.
Definitely something significant to mull over. Thanks for joining us for this deep dive into these sources today.
Keep it